Hope my slide is visible.
Yes, sir.
Okay. So today we are going to talk about experiment number 6, that is lathe machine. We are going to talk about the working and the understanding of lathe machine. The aim of this experiment is to understand and demonstrate construction and working of conventional manufacturing machine, and that is, so there are lots of other machines that come under conventional manufacturing machining, and one machine that we talk about today is called lathe machine, and we will also talk about what this conventional manufacturing machining is also all about. Let me first formally define what this lathe is all about. The lathe is a machine used for removing metal from workpiece to give required size and shape. So essentially, what this lathe does is, let's suppose you have a uh, chunk of iron ore or maybe cast iron, maybe the naive version of iron, maybe cast iron, okay, or maybe you have a chunk. So by some means, by some means or by some process or some machining process, I'm going to convert into a, a beautiful screw you might have seen in your homes. So have you seen a screw in your at your home? So this kind some sort of screw. So not only a screw, there are several n components, hundreds of thousands of components can be made from any raw material to uh, very advantageous uh, or maybe some sort of car components you want to make. You want to make some sort of door or maybe some panel, maybe wheel chassis or maybe chassis, or maybe uh, the skeleton of wheel or the other components you can actually easily make out of the raw material, and the process that it involves is called machining processes. And these machining processes, one of the process uh, where you are going to take the raw material as your cylindrical object, you are going to turn it and you are going to remove some extra material, and where the device called the machine called lathe is used. Okay. So this is the overview of where this lathe is going to be associated with and what is its purpose. So essentially we are going to uh, convert some sort of raw materials into some sort of advantageous uh, products that we will be needing in our day-to-day life. So we before starting, we can I just wanted to give you an overview of what exactly things are all about. So in mechanical engineering is broadly divided into three segments, that is thermal, design, so thermal engineering, design engineering, and manufacturing engineering. So the experiment number 1 to 5 was all about thermal engineering. We essentially talked about energy conservation work, heat transfer, and everything. Okay, so that comes under thermal engineering, and we have briefly seen things in from experiment 1 to experiment 5. Experiment 8, that is the last experiment, will be of design type. Okay, so in design means let's suppose you are making a car component. So in thermal engineering, you have seen that how your engine works and how much I mean certain fuel you want to add, and you are going to move your car. Okay, in design engineering, you actually want to design your car components. Okay, in some sense. So let's suppose your crankshaft or your piston or your panel or maybe some door or maybe some sort of window, maybe chassis. So this chassis is going to be built by some CAD modeling. Okay, maybe probably by some sort of CAD operations, or maybe in computer. Once it is the 3D model is being done, and then it undergoes some sort of stresses, stress, or some sort of loading, and these loadings will tell you whether your car is going to, your chassis is going to fail or not. Okay, whether this load can fracture this chassis or not. So all sorts of design parameters, how much load I can maximum this car can take. Okay, or how much bump it can take up this vibration. I mean, that is what the vibration, the shock absorbers are all about. The design of shock absorbers are all about how much bump is there, so you don't want to avoid it, or you want to make your journey more comfortable. So in that way you are going to design your components in such a way. So this comes under design section. So mechanical engineering has third component, is its manufacturing engineering, and we will talk about experiment number 6 and 7 under this manufacturing engineering. So this manufacturing engineering is all about making things, essentially your car components such as your door, chassis. Where does it come from actually? So it comes from, so you excavate your land. Okay, you excavate your land, you take out of iron ore. Okay, आप आयरन ओर निकालते हैं, उसको फिर प्रोसेस से गुजारते हैं, ठीक है, ब्लास्ट फर्नेस में डाल के कास्ट आयरन बनाते हैं. ओके, बाय सम प्रोसेसेस मे बी कास्टिंग, फिर उसको फोर्ज करते हैं, उस पर प्रेशर लगा के कुछ उसका शेप चेंज करते हैं, फोर्जिंग, एक्सट्रूजन. फिर उसके बाद एक रॉ मटेरियल ऐसा आता है, एक चंक टाइप का, प्रोबेबली मे बी दिस और मे बी सम सॉर्ट ऑफ ब्लॉक आपको मिलता है. इस ब्लॉक को फिर आप सम मशीनिंग प्रोसेस से गुजारते हैं, ठीक है. So it undergoes some sort of machining process, such as turning, maybe cutting, all sorts of, and then finally आपको, let's suppose एक component बना रहे हैं, तो let's suppose आपको screw मिला, और maybe door आप बना दिए. So this manufacturing engineering is all about making things from raw material to a advantageous product. So this mechanical engineering encompasses all these departments. We have already touched upon thermal, we will touch upon design engineering, and now we are going through manufacturing engineering actually. So this 6th chapter is all about conventional machining. And the 7th experiment would be unconventional machining. So conventional machining is all about, you will have hammer, you are going to mold it, you are going to tap it, you are going to forcefully do something. Okay, all those sorts of force, or all sorts of physical tools that may cut things comes under conventional machining. Okay, unconventional machining is all about chemical processes. Okay, sometimes you don't need it, you don't need to machine a component. You don't need always, you need a force. Sometimes you can actually do things through chemical processes. That comes under unconventional machining. So this lathe machine is all about conventional machining, and that too it falls under some sort of the workpiece you are going to use is axisymmetric. Means your tool is some sort of cylindrical workpiece you will take, and then you are going to remove things to make it screw or crankshaft or anything desirable thing you want. तो essentially आपका वर्क पीस जो है इसमें रोटेट होता रहता है, एक कटिंग टूल होता है. ओके, जैसे आप एप्पल को नाइफ से काटते हैं तो एप्पल कट जाता है. आई मीन इन सम एनालॉजिक सेंस you will have a workpiece and you have a cutting tool, and this cutting tool is going to cut these or remove these extra materials in order to make its shape proper or desirable shape. Okay, so this is the overview of lathe machine, and this is the overview of what we are, where we are actually. I mean, what under what mechanical stream we are working, I mean looking at. So we will talk about slightly more detail through manufacturing processes, so that we can have a feel of where we stand right now. So manufacturing processes are steps through which raw materials are being transformed into final material. So suppose you have an iron ore or a ingot or a cast iron, which is going to be undergone through some sort of primary processes such as forming, casting, molding. I'm not going to talk about details in this here because it will take another course to understand this. Then it undergoes secondary process, which is called machining process, and in which you should have turning, drilling, reaming, and threading if you have some sort of axis symmetric objects. Okay, if you don't have axis symmetric objects, let's suppose you have a flat surface to be removed, then you should have milling process. We are not going to talk about milling process in this course, in this particular experiment, but we are going to talk about the machining process. That too, your object or workpiece should be cylindrical in nature, which could be turned, which is going to be drilled, reamed, thread, and all sorts of things. And this could be achieved by your lathe machine. Okay, so this is where we lie. Okay, after that, once things have machined, it undergoes surface finishing such as polishing, honing. Again, you may take, I mean, you may want to join two materials, so that is why welding comes into picture. And after that, you will have some final products such as your screw, maybe your crankshaft, maybe your car components, and many more. Okay, and this is where we actually lie, and we are going to talk about this particular section. But just to give you a bird eye view of where we lie in manufacturing process is this one. Okay, now we talk about uh, something more. So we formally defined that lathe is a machine used for removing metal from workpiece to give its required size and shape. And workpiece rotates. So how it works? The workpiece rotates. So your workpiece is going to be uh, clamped on some 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 tools, and once it is clamped, it is going to be rotated. Once it is rotated, you will have a cutting tool, some sort of cutting tool, and you will feed it. You will try to um, cut through it by several operations. So it will have several ways to cut it. Okay, so we'll look into all those operations through a video because that would be more comprehensive to understand those operations. Because when I tell you, you may not understand what is happening, but in video it will be very clearly mentioned, and you can see things are moving, things are going, how things are going and moving and cutting things. So it will be advantageous if we look upon some sort of videos for these operations such as cutting, knurling, drilling, facing. So we'll talk about in video, not here. But I mean, as a bird eye view, or as a holistic sense, this lathe machine is all about removing the metal, excess metal out of your workpiece to give a desired shape or size, what you need it as your final product. Example of objects that can be made through lathe machine are screws, candlesticks, gun barrels, cue sticks, table legs, balls, baseball bats, musical instruments, and most important, crankshafts. Although all the components in a car, most of the components uh, are achieved through several machining processes, manufacturing processes. Uh, Through turning or through the lathe, there is a critical component is made, is called crankshaft, that we talked about in our IC engine. So in IC engine, we have a piston cylinder arrangement. So this is your cylinder, this is your piston which goes to and fro, and this is your connecting rod, this is your crankshaft, that is be here. So this is your crankshaft. This crankshaft is uh, made out of is actually uh, manufactured or machined by this lathe machine. So let me talk about briefly about what are the components, what are the main components of a typical lathe machine. So obviously we cannot show you our workshop. So in workshop we have all sorts of machines, machining machines. One of its, I mean, one of its kind is a lathe machine is there, and the size of this is pretty big. Okay, once you will be in the workshop, maybe soon, maybe this year end, or maybe I don't know, hopefully this year end, you guys may come into campus if things are good, eventually good. uh, you will be able to see it. Otherwise, I'll show you a video. Through that you will have a comprehensive idea of what it is all about. So this the first component is the headstock. So left part is called headstock, and here we have a motor. So motor, through motor there are some sort of gear arrangements. Through gear arrangement, there is an spindle which is going to rotate this through this axis, and in turn this rotates this chuck. So chuck is a place where your workpiece, your cylindrical workpiece, is going to be fixed at. So this is going to be fixed at chuck through jaws. Okay, so this part is called headstock. Another thing is called tailstock. So tailstock is kind of support mechanism. So whenever things are long, it is going to be held at from this end through tailstock, if at all it is long. Otherwise it is not needed. So if it is short enough, it is fixed on it is clamped on chuck through jaws. And there is another component called this component is called carriage. So carriage consists of cutting tool, like knife, or I mean, obviously there is a technique involved how these things cut, but we are not going to talk about anything in details, what angle we are going to cut and what is the uh, fundamentals behind cutting things. But just we in this lab we just going to take up things as a granted that okay, fine, we have a workpiece which is going to be rotated, and this cutting tool, this will be a projected cutting tool will come, and through this spindle you are going to move this forward or maybe lateral or all sorts of things. So this can go this way and this way, and this is the bed, and these are the legs. So this is a complete uh, overview of a typical lathe machine. This is how it looked like. When I show, I will show you video. It will be more comprehensive for you guys. Uh, okay, before showing the video, the machining processes, this I already talked about, has two classifications: traditional machining and non-traditional machining. And this is also called conventional machining, and this is called also called non-conventional. Okay, through which we are going to cut things or remove things by some sort of force or some sort of cutting tools. So if at all it is having, the raw material is having circular shapes, you are going to turn it, bone it, drill it, and this particular section uh, can be, these things can be done by lathe. Okay. If at all you have various shapes, such as your flat plate is there and you want to remove some extra material on top of it, you have to do it with milling operation. We are not going to talk about these things in this experiment, but these things are there, and all these things comes under conventional machining. You are going to make a force. You are applying some sort of force, or you will have a cutting tools in it. Whereas in non-conventional machining, you should have other means of removing the material, such as chemical processes. And this electrochemical machining we are going to take up in experiment number 7, which we will be going to do it in experiment in the next experiment. So all these things are there, but we will not be doing things in details. But you should know that these things are classified as non-conventional, and these things are conventional. Why conventional? Because the people from historical era, we are forging, we are casting things since long back, like it's thousands of years back. So this is a conventional way of doing machining. But since the advancement of technology has happened, we have several other techniques came up, and there are certain advantages and disadvantages. Here the material removal rate is very high and it's good, but here material removal rate is less, very less. And but the advantage here for non-conventional machine is, if at all you want to tap a hole tap a hole at some uh, hidden place, or maybe you cannot access it. Okay, that time you may not achieve it through by conventional machining. So for that you have to take help for non-conventional machining. If you want to tap a hole or drill a hole, or maybe you want to machine where you don't want you cannot access it, maybe in some hidden place, or maybe some place you cannot, your tool cannot access. So in that way the chemical processes are a bit advantageous way to do it. So that is why it is more popular these days for complex configurations. Anyways, so we have I have a very comprehensive video, and I'll run this video and hope this video uh, explains you everything. So I have already copied it here. Okay, um, for sound, let me unshare and share it again. For computer sound, you will be needing computer sound as well. So
Phasing operation. In this video, we will discuss the phasing operation in the lathe. Phase
so in this video they'll talk about several operations and how they are going to achieve it. So, and this will be self-explanatory, uh, and let's watch it first.
phasing operation. In this video, we will discuss the phasing operation in the lathe. Phasing is an operation which produces flat surfaces. Phasing tool, workpiece, chuck. In this operation, the tool is fed at right angles to the axis of the workpiece. It reduces the length of the workpiece. Various types of lathe operation we'll discuss in the next videos. Turning operation. In this video, we will discuss the turning operation of the lathe. Turning is the machining operation in which excess material is removed by rotating the workpiece against a cutting tool. Workpiece, tool, feed, that is F, depth of cut. Knurling operation. In this video, we will discuss about knurling operation in the lathe. It is the process of indentation of various forms on cylindrical surfaces. Knurling tool, workpiece. A knurl tool is held in tool post and pressed against the rotating work. It is done to provide grip on holders and screw heads. Grooving. In this video, we are going to see about grooving operation. Grooving is also known as recessing, undercutting, or necking. Consider a workpiece held in lathe. The grooving tool is fed crosswise against the rotating workpiece. A groove is the location of an indentation in the part. This indentation can be square, round, or angular in the shape. The function of a groove is usually to allow room for a fitting part such as a rubber O-ring. It could also be the place where another part fits into this part. Grooves also provide a relief in the backside of a thread where the thread terminates. Drilling. In this video, we will discuss the drilling operation of the lathe. It is the process of making holes on workpiece. The drill is fed slowly into the workpiece, which is revolving in a chuck. Workpiece drill tool. The drill is held stationary in the tailstock spindle. Reaming. In this video, we are going to see about reaming. Reaming is the operation of finishing and sizing a hole which has been previously drilled or bored. Consider a workpiece held in lathe. The tool used is called reamer, which has multiple cutting edges. The reamer is held on the tailstock spindle, either direct or through a drill chuck, and is held stationary while the work is revolved at a very slow speed. The speed varies from 0.5 to 2 millimeter per revolution. Hence, reaming is done. Boring operation. In this video, we will discuss the boring operation on the lathe. Boring is the operation of enlarging the previously drilled hole with the aid of single point cutting tool called boring tool. Workpiece boring tool. If the hole is enlarged only through a certain length, then it is referred as counter boring. If the tool is fed at an angle to the axis of rotation, it is called internal taper turning. Enlarged hole, parting off. In this video, we will discuss the parting off operation on the lathe. Workpiece, cutting off tool, parting off is the operation of separating the finished workpiece from a bar stock. The operation involves feeding the cutting tool into the rotating workpiece.
Okay.
In this video,
So my question is, I have one question to ask. So this is your workpiece and this is your tool. So what is the reason that tool cuts this workpiece, not this workpiece cuts this tool, cutting tool, other way around? So the reason being, the cutting tool is having higher hardness, or it is more tough or more hard. It is made in such a way that obviously the knife is going to cut your apple only if your knife material is more hard or more tough than your the object you are going to cut. So that is why. So don't I mean confuse it that this is made of same material. This cutting tool is made of some other hard material. So that is why it is able to cut it. So yes, that actually ends my uh, lecture. But let me just open uh, the lab manual once again. Let me show you what how so far what we have learned. So this is your experiment number 6. Um, So introduction lathe can, so this is the classification of lathes I didn't talk about. There are several other types of lathes as well. Usually in labs we have bench lathe or engine lathe, or sometimes automatic lathes are also available. I talked about constructional details such as bed, headstock, tailstock, carriage, feed mechanism, threading cut mechanism. This is a cut, overview of the components of the lathe. There are several other operations that we talked about or we have seen in our video. Some of them we have seen, some of them we have not seen, but you can always go and check what are other operations could look, because in this particular stipulated amount of time we cannot cover everything. uh, but yes, we can also thread it also, through these sort of operations, and you will be able to visualize it more clearly if you take up some videos on it. If you see some videos on it through YouTube or NPTEL lectures, I would suggest some NPTEL lectures you should watch, or some animation videos you should watch. And yes, that's it. So I would expect you to write an assignment on based on these 6 questions. First is draw and sketch and label the different components. Explain the procedure of performing straight turning operation that we have seen in our video in first. The second operation, the first operation was facing operation. Okay. Differentiate between facing and parting off. We talked about parting off at the end, cutting off totally from the job. Straight turning, shoulder turning, all these things you can actually do some uh, book search or internet search, and you can understand it and you can write it in your own words. So yes, uh, is this fair enough? You guys understood well, or
Yes,
anything
sir.
else you want to add, or you have any suggestion, anything? So if not, uh, so few of the people are um, shooting an email that they obviously, I know that this is a tough time. We have our family members in COVID situation, and even the student as well. So I agree that few of you are not able to submit the assignment. So we don't worry about it. We will take it late for you guys who is having some issues. We may take up late assignments, but don't worry about it. Don't become panic, and let's face this situation. It's happening with all of us. Okay. Probably it is going to be peak in next week, and then it is going to fall down. The IIT Kanpur researchers, the data scientists has already estimated or predicted the graph that it is going to go down from next week onwards, and let's hope for the best. Okay. Anything else, or shall we take attendance? Shall I take attendance? Okay, if no questions, and you know what you have to write, that those 6 questions you need to tackle, and you can write it in your own words and try to submit it. I'll make a folder. Okay, that's it from my side for today's lecture. I'm leaving it early. Please
Thank you,
stop
sir.
recording. Thank.
Thank you, sir.
Okay, thank you.